Hi students, I am Kailash. Today I will be teaching you what is the effect of introducing a dielectric material between the plates of a parallel plate capacitor, keeping the battery connected with the capacitor. So in the earlier class we saw what is the effect of introducing a dielectric material between the parallel plates of a capacitor and removing the battery from the capacitor. So battery capacitor disconnect பண்ணதுக்கு அப்புறம் அதோட ரெண்டு பிளேட்டுக்கு இடையில dielectric material introduce பண்றனால what really happens. So that we saw in the earlier class. So today what we are going to do is we are going to keep the battery connected with the capacitor, and then we are going to discuss so what is going to happen to the capacitance of the capacitor and what is going to happen to the energy what the capacitor stores. Okay, right. Now so you just go to the first diagram. If you look at the diagram, first diagram, so what we have here is a parallel plate capacitor. The upper plate is connected to positive of the battery and the lower plate is connected to negative of the battery. Let VO be the terminal potential difference of the battery. That is voltage offered by the source. Now once when we connect the capacitor to a battery, so we have studied electrons will be transferred from one plate to another plate through the battery, so that here the electrons will be transferred from upper plate to lower plate. The positive terminal of the battery will attract the electrons of the upper plate. So the electrons from the upper plate will travel through the battery and will get deposited on the lower plate. So thus the upper plate will acquire positive charge and the lower plate will acquire negative charge. Thus there exists a potential difference between the two plates of the capacitor. You know, positive charge means high potential, negative charge refers to low potential. Now how long the electrons keep transferring from upper plate to lower plate? So as the electrons keep transferring from upper plate to lower plate, the positive charge on the upper plate will go on increasing and the negative charge on the lower plate will go on increasing. The potential difference between the two plates of the capacitor will keep on increasing. So at one particular stage, the potential difference between the plates of the capacitor will equalize with the terminal potential difference of the battery. So at that stage, the electron transference will stop. Okay, right. So let VO be the potential difference across the two plates of the capacitor. You can see it's equal to the battery voltage. So the capacitor has attained that equilibrium. Another capacitor is said to be fully charged. Let E naught be the electric field between the two plates. You know, electric field always acts from positive charge to negative charge. And let A be the area of both the plates. Let A be the area of both the plates and D be the distance between the two plates. Okay, right. And so I will repeat, VO is the potential difference between the two plates of the capacitor. Before introducing dielectric, in fact, EO is the electric field between the two plates of the capacitor. Again, before introducing dielectric, A happens to be the area of both the plates of the capacitor and D is the distance between the two plates. Let Q naught be the charge present on the capacitor, or let Q naught be the charge stored by the capacitor before introducing dielectric material. Okay, right. Now, you know, capacitance C in terms of area of the plates and distance between the plates is given by epsilon naught into area of the plates divided by distance between the two plates. We have a formula for that. So let me write that formula. Before introducing the dielectric, let CO be the capacitance of the parallel plate capacitor. So dielectric introduce பண்றதுக்கு முன்னாடி நம்ம ரெஃபர் பண்ற terms, நம்ம டீல் பண்ற terms ஓட சப்ஸ்கிரிப்ட்ல O போட்டுக்கணும். அப்போ QO initial charge, VO initial potential difference, EO initial electric field, CO initial capacitance. Initialங்கற வேர்டுக்கு பதிலா original அப்படிங்கற வேர்ட் யூஸ் பண்ணிக்கலாம். Right. CO is equal to epsilon naught into area of the plates A divided by D. So don't forget this formula. Okay, right. Now what I am doing is I am introducing a dielectric material. You can see the shaded part. The entire space between the two plates is now filled with a dielectric material, an insulating material. Say for example, a mica sheet or even a paper. A paper is an excellent dielectric material, you know that. So, ரெண்டு பிளேட்டுக்கு இடையில இருக்கக்கூடிய இந்த entire space ஒரு dielectric material வச்சு நம்ம fill பண்ணிடலாம். Now, the distance between the two plates can also be called as thickness of the dielectric material. So, dielectric fill பண்ண உடனே இந்த term D நீங்க ரெண்டு விதமான வியூ பாயிண்ட்ல நீங்க பாருங்க. ஒன்னு distance between the two plates அப்படினு சொல்லலாம். Or thickness of the dielectric slab or dielectric material அப்படினு சொல்லலாம். ரெண்டு ஒண்ணுதான். கான்டெக்ஸ்ட் ஏத்த மாதிரி நம்ம அத மாத்திக்கலாம். Okay? Right, let epsilon r be the relative permittivity of dielectric material introduced between the two plates. Relative permittivity is otherwise called as dielectric constant. Okay. Now what will happen if I introduce a dielectric material between the two plates of a capacitor? So whenever a dielectric material is introduced between the plates of a capacitor, point number 1, the electric field between the two plates will decrease. By how many times? It will decrease by epsilon r times. So ரெண்டு பிளேட்டுக்கு இடையில இருக்கக்கூடிய electric field decrease ஆக try பண்ணும். The electric field will tend to decrease. Electric field was originally EO, isn't it? So it will tend to decrease. Electric field between the plates decrease ஆச்சுனா potential difference between the two plates will tend to decrease. See, அப்ப E naught decreases to E, for instance. Downward arrow mark வந்து it's a symbolic representation of decreases. It's my symbol, okay, right? Not a universal symbol. And VO decreases to V. Assume பண்ணிக்கலாம். அப்ப ரெண்டு பிளேட்டுக்கு இடையில இருக்கக்கூடிய potential difference dielectric introduce பண்ண உடனே decrease ஆகும். It will decrease to V. Now what happens? You can see the battery voltage is VO and the plate voltage originally was VO, which was equal to the battery voltage. So if battery voltage 10 volt அப்படினு assume பண்ணிட்டேன்னா கெபாசிட்டரோட ரெண்டு பிளேட்ஸ்க்கு இடையில இனிஷியலா 10 volt இருக்கும். இப்போ dielectric introduce பண்ண உடனே the potential difference will drop. It will decrease. It has become 8 volt ன்னு assume பண்ணிக்கலாம். Now if you look at the battery voltage, it is 10 volt. And if you look at the capacitor voltage, it is 8 volt. So battery voltage is more and capacitor voltage is less. You know, charges always flow from high potential or high voltage to low voltage. So now since the battery voltage is maintained high when compared with the capacitor voltage, the battery will supply additional charges to the capacitor plates. So charges will flow to the capacitor plates from the battery. Now already capacitor plate la charges irukku illingla. Ipo marubadiyum battery la irundhu charges additionally capacitor plate la store agum. Edhu varaikum keta decrease ana and the voltage marubadiyum battery voltage ku equalize agara varaikum charges will be transferred. So additional charges will be transferred from the battery to the capacitor. So now the capacitor will be storing more charges than before. So I have added 3 more charges, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. எவ்வளவு positive charges இருக்கோ அவ்வளவு negative charges போட்டுக்கங்க. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me draw it neatly. So what happens? Decrease on a potential difference, மறுபடியும் it will become VO. Since potential difference has become VO, the electric field will also become EO. Potential difference change ஆச்சுனா electric field உங்களுக்கு change ஆகும். Because you know, electric field is equal to potential difference divided by distance. Let me put it in words. So potential difference change ஆச்சுனா electric field will change ஆகும். Okay? So since the potential difference has increased from V to VO, decrease on electric field E ல இருந்து மறுபடியும் ஆட்டோமேட்டிக்கா என்னவா மாறிடுங்க E நாட்டா மாறிடும். So what is the net result அப்படினு பாத்தீங்கன்னா dielectric introduce பண்ணி பேட்டரியை டிஸ்கனெக்ட் பண்ணாம வெச்சிருந்தோம்னா electric field between the two plates does not change. It will remain the same EO as before. Potential difference between the two plates will not change. It will remain VO as before. But what happens is, before introducing dielectric, the charge of the capacitor is Q. But after introducing the dielectric, the potential difference between the plates tend to decrease. But the potential difference between the plates decrease ஆகும். ஆனா additionally batteryல இருந்து charges capacitor plate மேல store ஆகறனால the potential difference is brought back to the original value VO, isn't it? அப்ப capacitor plateல additionally என்ன ஆகுதுங்க, charges நமக்கு store ஆகுது. So what happens is the charge stored by the capacitor will change from QO to say Q. So whenever a dielectric material is introduced between the two plates of a parallel plate capacitor, keeping the battery connected with the capacitor, the electric field will remain the same VO. Potential difference between the two plates will remain the same VO. The charge on the capacitor will increase from Q0 to Q. And epsilon R, as before, is the dielectric constant of the dielectric material. D, thickness of the dielectric slab or distance between the two plates. And A is the area of the two plates. Okay, right. So charge increase now we can show that the charge Q after introducing the dielectric will be equal to epsilon R times QO. So I told charge on the capacitor has got increased. எவ்வளவு times charge increase ஆகும் கேட்டிங்கன்னா, நீங்க introduce பண்ண dielectric material ஓட dielectric constant times increase ஆகும். Suppose if initial charge is say 10 coulomb and the dielectric constant what you have introduced is say 1.5, then the new charge what the capacitor stores will be equal to 10 into 1.5, that is nothing but 15 coulomb. So take this as number 1. So Q is equal to epsilon R into Q0. Is it clear? Okay. Now we are supposed to find what happens to the capacitance after introducing the dielectric and what happens to the energy stored by the capacitor after introducing dielectric. So first we shall see what happens to the capacitance after introducing the dielectric material, of course keeping the battery connected with the capacitor plates. Okay. So before introducing the dielectric, let CO be the capacitance. You know, capacitance is equal to, it's the ratio of charge to the potential. Now CO is equal, this is before introducing dielectric. Now what is the charge stored by the capacitor before introducing dielectric? It is QO. What is the potential difference between the plates before introducing dielectric? It is VO. So CO is equal to QO divided by VO. Let it be number 2. Now let us find capacitance of the same capacitor after introducing dielectric. After introducing the dielectric, let's see its capacitance. Let me write it somewhere over here. So C is equal to, now what is the charge stored by the capacitor after introducing dielectric? It is Q divided by, what is the potential difference between the two plates after introducing dielectric? It is the same VO. So let me take it as number 3. Now let me substitute 1 in 3. That is, instead of Q, let me use epsilon R into Q0. Use pannalama. So capacitance C after introducing dielectric is equal to Q ku badala epsilon R into Q0 divided by VO. What is Q0 by VO? Q0 by VO, as per equation 2, is the capacitance of the capacitor before introducing dielectric material. So let me take this as number 4. Now I am going to substitute 2 in 4. That is, instead of QO by VO, I will be substituting C0. So hence, I will end up with capacitance C after introducing the dielectric material equals to epsilon R, keep it as such, QO by VO as per equation 2 is capacitance before introducing dielectric material, that is CO. So thus capacitance of the capacitor after introducing dielectric will become epsilon R times the capacitance before introducing dielectric material. You know, all the dielectric materials will have epsilon R greater than 1. So whenever I multiply anything by a number greater than 1, the product will increase. For example, if I consider epsilon r to be 1.5, it's greater than 1, and CO to be, for example, 5, and if I multiply these two, the product, that is nothing but C, will become 7.5. So whenever I multiply a number by a value greater than 1, the result will always increase. So it's a simple elementary mathematical fact. So since epsilon r is greater than 1, when I multiply it with C naught, the result, what I get is C has to be greater than C naught. 7.5 greater than 5. So I can conclude from equation 5 that C is greater than C naught. So when I introduce a dielectric material between the two plates of a capacitor, and if I keep the battery connected with the capacitor, the capacitance of the capacitor will increase. By how many times? Epsilon r times. Is it clear? Right. Now we have to check what happens to energy stored by the capacitor. Energy stored by the capacitor. Right. It's very simple. Now let us find the energy stored by the capacitor before introducing dielectric. So U sub O, half into CO into VO square. So let me take it as number 6. So CO is the capacitance before introducing dielectric, and VO is the potential difference before introducing dielectric, and UO is the energy stored by the capacitor before introducing dielectric. Now after introducing dielectric, the energy, energy stored formula is half into CV square, capacitance into square of the potential difference, right? Okay. So after introducing dielectric, let epsilon be the energy. Say epsilon, the symbol for potential energy. Okay. So epsilon, that is U, equals half into capacitance of the capacitor after introducing dielectric to C, and potential difference remains the same, VO, isn't it? So VO square. This is number 7. Now if I substitute phi over here, we know capacitance C after introducing dielectric is equal to epsilon r into CO. So let me substitute it over here. So half into, so C ke badala epsilon r into CO potukkalam. Epsilon r into CO into VO square. Now let me write it like this. Epsilon r into half CO VO square. Now what is half CO VO square? It is nothing but energy stored before introducing dielectric. So what's your conclusion? Energy stored by the capacitor will increase by epsilon r times. If you look at this expression, the energy stored before introducing dielectric is multiplied by epsilon r. If anything is multiplied by a value greater than 1, the result will increase. So which means the energy stored will be greater than the energy stored before introducing dielectric material. Okay, so that's all. Thank you. Hi students, we will consolidate the effect of introducing dielectric, keeping the battery connected with the capacitor and removing the battery from the capacitor. Okay, right. So first, battery is disconnected from the capacitor, and then we are introducing dielectric. So what are the things we observe? Number 1, the electric field between the two plates will decrease. It will decrease by how many times? Epsilon r times. The potential difference between the two plates will also decrease. By how many times? Epsilon r times. So these are all objective point of view. Romba important. This base panni problem kepanga. The essence of the so this is the essence of the two topics what you learned. Effect of introducing dielectric. Okay, so that's what I am consolidating. And the capacitance of the capacitor increased. So increase by how many times? Epsilon r times. And the energy stored by the capacitor will decrease by epsilon r times. Okay, right. And one thing will remain constant. So when the battery is disconnected and if I introduce a dielectric material, one thing will remain constant. What is that? The charge will remain constant. The charge on the capacitor plate remains constant. Okay? Right. அடுத்தது பேட்டரியை நம்ம டிஸ்கனெக்ட் பண்ணாம capacitor plates ஓட அப்படியே வச்சிருந்து dielectric material introduce panna, what happens? So when the battery is kept connected with the charge of the capacitor and then if I introduce a dielectric, we just saw electric field remains constant. It doesn't change. It remains the same. Potential difference remains constant. It doesn't change. Capacitance increases by epsilon r times. And the energy stored by the capacitor will also increase by epsilon r times. As well as the charge will also increase by epsilon r times. So charge increases by epsilon r times. So all these things you can observe when the battery is kept connected with the plates of the capacitor. And then we introduce a dielectric material. But in both the cases, if you look at the capacitance, it increases. So what is the advantage of introducing dielectric material between the plates of a capacitor? The dielectric material introduced between the plates of the capacitor is of course going to increase the charge storing ability of a capacitor. That is the capacitance. Whether the battery is kept connected or disconnected, that doesn't matter. So that is the advantage of doing an improvisation. That is introducing a dielectric between the plates of a parallel plate capacitor. But the capacitance in both these cases increases in a different way. The reason why the capacitance increases is because of, number one, as far as the first case is concerned, where we disconnect the battery, the increase in capacitance is due to decrease in potential difference, because you know C is equal to Q by V. C is equal to Q by V. Capacitance is the ratio of charge to potential. If Q is constant, as in the first case, if Q is constant and if I remove this, so whenever I remove a constant term from an equation, the equal sign will change to proportional sign, isn't it? So 1 by V, proportional to 1 by V. So since capacitance is inversely proportional to potential, if the potential decreases, the capacitance will increase. So in the first case, when we disconnect the battery, the charge doesn't change. The charge on the capacitor remains constant. But the potential difference decreases, which implies the capacitance being inversely proportional to voltage when the charge is kept constant, and since the potential difference decreases, the capacitance will increase. So in the first case, to be short, the capacitance increases due to decrease in potential difference and the charge remaining constant. Whereas in the second case you can see C is equal to Q by V. The charge on the capacitor plates increases. How many times, that doesn't matter, increases. So charge increases. Whereas the potential difference remains constant. So V is constant. So let me remove the constant from this expression. See, whenever we introduce a constant, proportional sign will change to equal sign. And whenever we remove the constant from an equation, equal sign will change to proportional sign. So we can see when potential difference remains constant, the capacitance is directly proportional to charge what the capacitor plate stores. So more the charge, more will be the capacitance, lesser the charge, lesser will be the capacitance. Upon second case, when the battery is kept connected, the increase in capacitance is due to increase in charge. Whereas when the battery is disconnected from the plates of the capacitor, the increase in capacitance is due to decrease in potential difference. So capacitance increase agudhu, but the reason why it increases is different in both the cases. Okay, so thank you.